Hello, I'm Shevya Badoria and I'm your physics teacher, and today I'm going to explain you about gravitation chapter. So firstly, I want to tell you what the meaning of gravitation. What do you understand by that? What is gravitation force? What is gravity? The gravitational force or gravity both are same, but somewhere we said gravitational force and somewhere we said gravity. So what is gravity? Like you see that I'm just using some types of word which have you seen in your daily life. So like trees, raining water, river water, even atmosphere. So holding the atmosphere by what? By gravitational force. River water fall down on the ground. Why? Because of gravitational force. And I told you gravitational force is nothing, it's a gravity. Okay. And tree fruits, tree leaves always fall down on the ground. Why? Because of gravitational force, means because of gravity. This is just a normal type of introduction about gravity. Now I'm gonna explain you deeply with my notes. Okay. Yeah, so this is my topic name, gravitation. And now I want to tell you about this. What is gravity? The earth attract your pull all the objects towards its center. The attractive force, we said that this is a gravitation. Now you have a question. There is no repulsive force, ma'am? No, there is no repulsive force. This repulsive force we will study in charge, we will study in magnetic field, not in gravitational chapter. Okay. The force with which the earth pulls the object towards, it is called gravity. The main thing is that there is something missing. The force with the earth pulls the object towards its center is called gravity of earth. Yeah, it's called gravity. Example, I already told you in my first way what the gravitational force of earth is responsible for holding the atmosphere above the earth. Flow of water in river, how it always it always fall down on the ground. Keeping human firmly to the ground, how you are not floating here and there. That's the reason, because of gravity, keeping human firmly to the ground. Okay. According to Newton law, who gave this law? This law was given by Newton. Newton said that every object in the universe attract every other object. The force of attraction, what we will call gravitational force. Mass of the object are directly related to the gravitational force. How? I will tell you. Don't worry. Firstly, what this picture explain you? This picture is said to you. Newton said that an apple falls down because there is some force, and this force we call gravity. And this force exerted by your earth. Okay? Okay, next one. Universal law of gravitation. So the universal law of gravitation was given by Newton, is also known as Newton law of gravitation. So what this law will tell you? This law is said that every body in the universe attract every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of distance between them. How? Just wait. Where's my pen? Like suppose you have two bodies. Okay, I'm just making like, yeah. First body name is like A, second body is B. Okay, and in between them there is a distance and which is denoted by R. If you want, then you can denote by D also, but I'm using R. Okay, this A object have mass M1 and this B body object have mass M2. Okay, so I said that if you want to find the force between them, how much force exerted by two objects, so you can use this formula. And this formula, this definition was given by Newton. So what this is, I told you force is directly proportional product of their masses, matlab we are doing multiply of their masses. Okay, so it's what the mean of directly. Directly proportional means if mass will get increased, yeah, if mass increases, then your force will get increased. Yeah, your force is start increasing. Okay, and then I said this next second line, inversely proportional to the square of distance between them. So force inversely proportional to the square of distance between them. So what the mean of this inversely proportional? Inversely proportional mean that if you increase the distance, your force will start decreasing. Okay, and if you start increasing your force, then your distance start decreasing. So the main thing is that if you are taking object like this, it means that its force of attraction is very high, it's very large. But when you are taking those mass, yeah, these masses like very far distance, so distance will get increased. Yeah, distance is increases. So here force of attraction start decreasing because distance is increased now. And I told you, when you start increasing your distance, your force of attraction will start decreasing. I hope this one is clear. Now you said that, ma'am, it's totally looking like as a magnet. Here, its property is looking like as a magnet. When you are taking two magnets and you are just going so close, its force of attraction is so high, so large. But when you are giving lots of distance between them, when you are putting so much distance between this, so what you notice, its force of attraction start decreasing. Same here. I hope this one is clear. So when you combine this equation, what you will get, this is your first and this is your second equation. And when you combine, wait, I used black pen. Yeah, better. So what you will get, force directly proportional M1. Yeah, wait a minute. M1, M2 upon square of distance between them. Okay, when you remove this directly sign, what you will get? You will get F equals to G, capital G. What is capital G? This is a gravity.